For question 1, let's call the missing probability x. So 0.38 plus 0.24 plus x plus 0.16 must be equal to 1. And if you solve this for x, you will get 0.22. For part B, I will just add the two required probabilities. So 0.24 plus 0.16 will give me 0.4. For question A, I'll start by calculating the total amount saved in 2021, and this is equal to 78 times 12 months, that's 936. Now, if I have an increase of p%, that means that my multiplying factor will be 100 plus p over 100, and then I'll just use the formula original times the multiplying factor equals to the final amount. In this case, the original is the 2020 amount, so 720 times multiplying factor will give me the 2021 amount, which is 936. So the multiplying factor is 936 over 720, which is 1.3. Hence, 100 plus p over 100 is 1.3. Let's cross multiply. 100 plus p is 130. So p is equal to 30%. Alternatively, you can use the fact that percentage increase is equal to the final amount minus the original divided by the original times 100. Hence, if I substitute 936 minus 720 over 720 times 100 is equal to 30%. For part B, I have two coupons. For the first one, I get 18% off, so the multiplying factor for this coupon is 82 over 100, which is 0.82. For the second one, I get 12.5% off, so the multiplying factor is 87.5 over 100, that's 0.875 as a decimal. So using coupon A, you get 18% off the accommodation, so 1600 times 0.82, and then I need to add the flight cost, which is 800. This will give me 2,112. For coupon B, I am allowed a 12.5% in the total cost, so 1600 plus 800, and then I will multiply this by the multiplying factor 0.875. This will give me 2100, and because 2112 is bigger than 2100, he should select coupon B. For part A of question 3, I'll start by taking the 5 to the other side. So 4y is bigger than 7. So y is bigger than 7 over 4. For part B, I will cross multiply. 12x minus 10 equals 4x minus 7. I'll take the x's to the left, so 8x equals, and then take the minus 10 to the other side, it becomes 3. So x is 3 over 8. For question 4, note that both polygons are regular, which means all their sides are equal. And since they have a side in common, that is A and B, that means all sides of both shapes are the same. So let's indicate that on the diagram. Now I'm interested in the triangle BIC, which is this one. Now this is an isosceles triangle, so let's extract this outside the shape. So since this is an isosceles, I've labeled two of the angles X and the other one Y. Now I'm going to use the formula for each interior angle in a regular polygon, which is the following. To find the interior angle of the pentagon, and then the interior angle of the octagon, and then subtract them to find angle Y and hence angle X. So interior angle of the octagon is equal to 8 minus 2 times 180 over 8 will give me 135. The interior angle of the pentagon is equal to 5 minus 2 times 180 over 5 is equal to 108. And if I subtract those two angles, I will get 27, and that is angle Y, which is this one. So now I can use the fact that BIC is an isosceles triangle to find angle X. So X plus Y is 180. 2X plus 27 is 180. X comes out to be 76.5, and this is my final answer. In question 5, I have a compound interest of 2.5% per year. This means that my multiplying factor will be 102.5 over 100. As a decimal, that's 1.025. Hence, using the formula, initial value times the multiplying factor to the power of 3 equals to the final value. I can just substitute the values in to get the final amount. So 7,200 times 1.025 to the power of 3 will give me the final amount, which is 7,753.61. And if I round this to the nearest integer, I get 7,754. For question 6, part A, anything to the power of 0 comes out to be 1. For part B, I'll need to add those two powers. So 2 to the 6 is equal to the power of n, which means that n is equal to 6. Similarly, for part C, I will add those two powers first. So 7 to the 206 plus m over 7 to the 214 is equal to 7 to the minus 3. And then I will subtract those two powers. This will give me 7 to the minus 8 plus m equals 7 to the minus 3. Hence, if I equate the two powers, I will get minus 8 plus m equals to minus 3. Hence, m is equal to 5. For part A of question 7, the equation of any straight line is in the form y equals mx plus c. Now my gradient is minus 3, that's m. The y-intercept is 5, since the x-coordinate here is 0. So the equation of this straight line is y equals minus 3x plus 5. For part B, I'll consider the corresponding equations. So the first one would be x equals to 6 next one y is equal to 2, and finally y equals x plus 1. So if I plot the first one, x equals 6 is a vertical line cutting the x-axis at 6. Y equals 2 is a horizontal line cutting the y-axis at 2. And for the last one, I will create a table of x and y values. I will enter some x values, for example, 0, 4, and 8. And I will calculate the corresponding y values using this formula. So when x is 0, y is 1. When x is 4, y is 5. When x is 8, y is 9. Let's plot those points. If I join those points, I will get the required line. Finally, I need to consider which region I need relative to each line. So for the first one, x is less than or equal to 6. I need the region to the left of the line x equals 6. For y is bigger than or equal to 2, I need the region above the line y is equal to 2. And finally, for the line y less than or equal to x plus 1, I need the region below the line y equals to x plus 1. So the required region is the region inside that triangle. Let's shade and label with R. For question 8, I'll copy this table, add another row and another column. The extra column is to denote the total, and the extra row is for the sum, which is equal to sigma x, that can be found by rearranging the formula for the mean. So sigma x is equal mean times n. So far we know that number of Siberian tigers is 22, number of Bengal tigers is equal to 28, hence the total number of tigers is equal to 50. I know that the mean weight of the Siberian tigers is equal to 260, and the overall mean of 50 tigers is 218. Now I can find the total for the Siberian and for all 50 tigers by multiplying the number of tigers by the mean. So 22 times 260 will give me 5,720, and similarly 50 times 218 is equal to 10,900. So to find the total for the Bengal tigers, I will just subtract 10,900 minus 5,720, and this will give me 5,180. And finally, to find the mean of the Bengal tigers, I'll just do 5,180 divided by 28, and this will give me 185, which is the final answer. For question 9, the length AFEDC, which I need to find, is the following. Now to do so, I will first find AC. I will subtract FD, which is 6, and then add FED, which is a semicircle. So to find the straight line from A to C, I will use cos 30 is equal to adjacent over hypotenuse AC. Hence, AC is equal to 24 over cos 30. This comes out to be 16 square root of 3, which is approximately 27, 71, and so on. Now the semicircle DEF is equal half times 2 pi r. If I cancel out the 1 over 2 with the 2, I'll get pi r. R is equal to 3. So this will give me 3 pi. Hence, AFEDC is equal to 16 square root of 3 minus 6. That's the distance from F to D, plus 3 pi, which is the semicircle, and this will give me 31.13 and so on. I need my answer to two significant figures, so the final answer will be 31 centimeters. For question 10, to find the amount spent per person, I'll divide the total amount spent by the total population. So for Luxembourg, this is equal to 3.7 times 10 to the 9 over 6.3 times 10 to the 5. Put this on the calculator, you get 5,873.02. Repeat for Austria, that's 4.2 times 10 to the power of 10 over 8.7 times 10 to the power of 6. This gives me 4,827.59. And if you subtract, you will get 1,045.42. And to the nearest integer, this is $1,045. For part A of question 11, I'll just put these x values in this equation and calculate the y values. And the missing y values are 12, 3, 1.5, and 1.2. For part B, I will plot these points on this grid. Let me zoom out a bit. So plotting the points will give me the following. And then I will join them using a smooth curve. And that's the final answer. In question 12, the angle of depression of B from D is the following. And in order to find this angle, I'll use the following right angle triangle. Let's call this point here E. So in order to find the distance BE, I will subtract 30.7 minus 6.2, which will give me 24.5. And now let's extract this blue triangle. And in order to find angle X, I'll do tan of X equals opposite over the adjacent. Hence, X is equal to inverse tan of this fraction. Putting this on the calculator will give you 5.7 to 1 decimal place. In question 13, I'm given these two numbers, and if I multiply a minus b times a plus b, I should be able to write the answer in this form. Now note that this is not in the simplest form. I can split this into y square root of 4 times square root of y. Square root of 4 is equal to 2. So I can write this as 2y square root of y. So let's begin a minus b is equal to square root of 8 plus 4 minus square root of 8 minus 4. I'll expand the brackets, square root of 8 plus 4 minus square root of 8, and then minus minus 4 will give me plus 4. The square root of 8 with the minus square root of 8 cancel out, and I'm left with an 8. Similarly, a plus b will give me square root of 8 plus 4 plus square root of 8 minus 4. Again, remove the brackets, square root of 8 plus 4 plus square root of 8 minus 4. This time, the 4 and the minus 4 cancels out, and I'm left with 2 square root of 8. Hence, a minus b times a plus b is equal to 8 times 2 square root of 8. And if I compare this with what I'm supposed to show, y is equal to 8. In question 24, I'm given a cumulative frequency graph for the marks of a group of 60 students. In part A, I need to find the median. 60 divided by 2 is equal to 30. I'll go on 30 on the vertical axis and find the corresponding x value. The value on the x-axis is 48, and this is my median. For part B, I need to use the graph to find an estimate for the number of students who gain 58 marks or less. This time, I'll go on the horizontal axis, locate 58, and find the corresponding value on the vertical axis. The reading here is 46, and that's the required value. Note the mark scheme gives anything between 45.5 up to 46.5. In part C, I need to find the interquartile range. Now the interquartile range is Q3 minus Q1. To find Q1, I will calculate a quarter of 60, that is 15, so I need the 15th value. For Q3, I'll calculate 3/4 of 60, that's 45, so I need the 45th value. So I'll do a similar thing that I did in part A, starting from the vertical axis. I'll go to 15 and 45 and find the corresponding x values. The two readings I get are 40 and 56. So Q1 is 40, Q3 is 56, and if I subtract those, I'll get an IQR of 16. The mark scheme accepts any value from 16 to 18. In part D, it says the interquartile range of the marks gained in geography is 9. Louis says the students' marks are more spread out in the algebra test than in the geometry. Is Louis correct? And give a reason for your answer. The answer is yes, because the IQR is larger for the algebra test. Finally, in part E, to be awarded a grade A in the algebra test, a student had to gain a mark greater than 64. 2 students are to be selected at random from the 60. We need to use the graph to find an estimate of the probability that both of these students were awarded a grade A in the algebra test. Let's start by finding the number of students with a mark greater than 64. To find this, I'll work with a similar way as I did in part B. I'll start from the x-axis at 64 and find the corresponding y value. From the graph, I get a value of 50, but those 50 students got a mark less than 64. So to find the number of students with a mark bigger than 64, I'll do the total minus 50, which is equal to 10. And finally, to find the probability that both students were awarded a grade A, I'll multiply 10 times 60 for the first student times 9 over 59 for the second. This is like sampling without replacements, and this will come out to be 3 over 118. Note that the mark scheme accepts using a 51 here, which implies a 9 here. So a calculation of 9 over 60 times 8 over 59, which gives 6 out of 295, is also acceptable. I'll start question 15 by cross multiplying, so I get n squared t to the power of 3 is equal to 4d plus t to the power of 3. Now I need to get all the t's on one side, so I'll take this to the left. N squared t to the power of 3 minus t to the power of 3 is equal to 4d. Now I'll take t cubed as a common factor. I'll have n squared minus 1, and then on the other side 4d. I'll then proceed to divide by n squared minus 1, and finally I will take the cube root of the right hand side, and this is my final answer. In question 16, I will need the following two formulae, and the two triangles I will work with are the blue and the red. Starting with the blue triangle, this has an area of 405 cm squared, and I'll use the second formula to find angle C. So let's write again the formula using the correct letters. Area equals 1 over 2 bindi sine C. 405 equals 1 over 2 times 45 times 36 sine of C. So 405 divided by 1 over 2 times 45 times 36 equals to sine C. Sine C comes out to be 1 over 2. Hence, C is the inverse sine of 1 over 2, which comes out to be 30 degrees. I'll continue working on the blue triangle, and I'll use the cosine rule to find BD. So the formula becomes C squared is equal to B squared plus D squared minus 2BD cos of C. Let's put in the values. C squared is equal to 45 squared plus 36 squared minus 2 times 45 times 36 times cos of 30. This comes out to be 515.07 and so on. So C is equal to 22.695 and so on. So now I'll use the red triangle with the 22.695 I found in order to calculate angle B. To do so, I'll use the cosine rule again. B squared is equal to A squared plus D squared minus 2A in D cos of B. I'll rearrange this to get cos B on its own. So B squared minus A squared minus D squared all over minus 2A in D is equal to cos B. Let's substitute the values in. Cos B is equal to 28 squared minus 22.695 and so on squared minus 19 squared over minus 2 times 22.695 times 19. This will give me 0.1067 and so on. So angle B is equal to the inverse cos of this number, which comes out to be 83.9 degrees to 1 decimal place. In question 17, I need to find an estimate for the gradient of this curve at the point where x equals 2. That's the point here. I'll start by drawing the tangent at that point, and then I'll find the gradient of the tangent. Now, to find the gradient of the tangent, I'll need to use the following formula. The points I will select will be as far as possible. So I'll take these 2 points. The coordinate of those points are 0.3 minus 3 and 4 with 5.8. So the gradient is equal to 5.8 minus 3 over 4 minus 0.3. This comes out to be 2.38. Note that the mark scheme accepts any answer between 1.5 up to 3. In question 18, I'll need to solve these 2 equations simultaneously, but before I do so, I'll rearrange the first one into the form x equals 2y minus 1. So now I can substitute 2y minus 1 in place of x. So I have 3y squared plus 7y plus 16 equals 2y minus 1 squared minus 2y minus 1. So let's expand now. 3y squared plus 7y plus 16 equals 4y squared minus 4y plus 1 minus 2y plus 1. The plus at the end is because of the minus minus. Now I'll take everything to the right. So 0 is equal to y squared minus 13y minus 14. If I factorize, I'll get y minus 14 times y plus 1. So the y values I get are 14 or minus 1. And now I'm going to substitute these into this blue equation to get the x values. So x is equal to 2 times 14 minus 1. X comes out to be 27, or x is equal to 2 times minus 1 minus 1, x comes out to be minus 3. So the coordinates of A and B are 27 with 14 and minus 3 with minus 1. For question 19, I'll start working with the triangle ABC and work out side AC. So let's extract this triangle. So using Pythagoras theorem, AC squared is equal to 18 squared plus 8 squared. This is equal to 388, which means that AC is the square root of 388. That's approximately 19.697 and so on. So now let's go to our 3D shape again. I need to work with triangle ACE. This is a right angle triangle which is standing perpendicular to the floor, and I need to work out the angle ACE. So again, let's extract this triangle. To find angle C, I'll use the tan ratio. So tan C equals to opposite over adjacent. So C is inverse tan of this number. Put this on the calculator. It's going to give you 31.421 decimal place. For question 20, I have two statements. From each of those statements, I can get an equation. From the blue one, I get the following equation: y equals k1 over the square root of x, where k1 is a constant of proportionality. And from the red one, I get x equals k2 times t to the power of 3, where k2 is another constant of proportionality. Now I will merge those two to get an equation with y and t. I will replace x in the blue one with k2 times t to the power of 3. So y equals k1 over the square root of k2 t to the power of 3. I will split my denominator into 2. So y equals k1 over the square root of k2 times the square root of t to the power of 3. And I will consider this as a new constant. I will label this as k. So my equation now becomes y equals k over the square root of t to the power of 3. To find k, I will substitute these two values in my equation. So 8 is equal to k over the square root of 25 to the power of 3. And if I cross multiply and put this on the calculator, k comes out to be 1000. So my equation is y equals 1000 over the square root of t to the power of 3. In order to find t when y is 27, I will just replace y with 27 and solve for t. So 27 equals 1000 over the square root of t to the power of 3. Let's cross multiply. Square root of t to the power of 3 equals 1000 over 27. T to the power of 3 is equal to 1000 over 27 squared. So t is the cube root of 1000 over 27 squared. And if I put this on the calculator, I will get 100 over 9, which is the final answer. In question 21, I'm given this solid. I am given its area and the mass, and I need to find which one from this list the solid is. Now I know that density is equal to mass over volume, so I'll find the volume, divide mass by the volume, find the density, and look this up from this table. In order to find the volume, I'll first use the area to find x, and then I'll be able to find the volume. So surface area is equal to half a sphere, so 1 over 2 for pi r squared, plus the curved surface area of the cylinder, that's 2 pi r h, plus the circle at the base, that's pi r squared. So 81 pi is equal to, this will cancel out, so I'll have 2 pi x squared plus 2 pi x times 3x for the height, plus pi x squared. So 81 pi is equal to pi x squared plus 6 pi x squared plus pi x squared. Hence 81 pi is equal to 9 pi x squared. This means that x squared is equal 81 pi over 9 pi, which simplifies to 9, so x is equal to 3. To find the volume, I will add half a volume of a sphere plus the volume of a cylinder, so that's 2/3 pi 3 to the power of 3 plus pi 3 squared times 9 for the height. This gives me 18 pi plus 81 pi, which is equal to 99 pi. Hence, the density, which is mass over volume, comes out to be 840 over 99 pi, which is equal to 2.7. And if you look at the table, that's the density of aluminium. So our solid is made up from aluminium. For question 22, I have a right angle triangle and I'm given the coordinates of the 3 vertices. I'm also given the gradient of the hypotenuse, and I know that because of the right angle, the 2 sides are perpendicular, so I will create 2 simultaneous equations, and when I solve them, I should find the values of P and Q. To do so, I'll need the following 2 formulae. So let's start by creating an equation using the fact that the gradient of AC is minus 6 over 7. So using the first formula, the gradient of AC is equal to Q minus 10 over 8 minus P. This is equal to minus 6 over 7. If I cross multiply, I'll get 7Q minus 70 is equal to minus 48 plus 6P. I'll take the P and the Q on the same side, so minus 6P plus 7Q is equal to 22, and that's the first equation I will solve simultaneously. For the second equation, I'll first find the gradients of the lines A and B and BC, multiply them, set them to minus 1, and then that will be the second equation. So gradient of A and B is equal to 10 minus minus 5 over P minus minus 1. This comes out to be 15 over P plus 1. And the gradient of BC is equal to Q minus minus 5 over 8 minus minus 1. this is q plus 5 over 9. So if I multiply those two gradients, I should get minus 1 because the lines A and B and BC are perpendicular. So 15 over p plus 1 times q plus 5 over 9 is equal to minus 1. Let's simplify here. Both 15 and 9 are divided by 3. So now if I multiply the two fractions, I'll get 5q plus 5 over 3 p plus 1 equals minus 1. I'll continue on the side. Cross multiply, so 5q plus 5 is equal to minus 3 p plus 1. Let's expand. 5q plus 25 is equal to minus 3p minus 3. I'll take p and q on the same side, so 3p plus 5q is equal to minus 28, and that's the second equation. So I will rewrite equation 1 minus 6p plus 7q equals 22. I will multiply the second equation by 2, so I get 6p plus 10q equals minus 56. Now I will add those two equations. The minus 6 with the 6p cancel out, so 17q equals to minus 34. Q is equal to minus 2, and if I substitute in equation 2, I will get 3p plus 5 times minus 2 is equal minus 28. So 3p is equal minus 18. P comes out to be minus 6. So minus 6 and minus 2 are the two final solutions. For question 23, I'll start by finding the composite function f g of x. I will take the function g and use it as an input in function f. So this will give me x squared minus 12x and then plus 25. And in order to find the inverse, I'll first have to complete the square. So I get x minus half of 12, which is 6, squared minus 6 squared, and plus 25. So x minus 6 squared minus 36 plus 25, which gives me x minus 6 squared minus 11. To find the inverse, exchange the rows of y and x. So x equals y minus 6 squared minus 11. And let's get the y on its own. So x plus 11 equals y minus 6 squared, plus or minus the square roots of the left-hand side equals y minus 6. So y comes out to be 6 plus or minus the square root of x plus 11. Now I have to make a choice between the plus or the minus. To make this decision, I'll go see the domain of function h. And this is all the x values less than or equal to 6. Now the domain of h is equivalent to the range of the inverse of h. This means that the range of inverse h is all the y values such that y is less than or equal to 6. So if I come down here, for my inverse to be valid, I need all the y values less than or equal to 6. Hence, I will take the minus to make sure that all y's are less than or equal to 6. So the inverse age is 6 minus square root of x plus 11.